And some of this is a review from last semester, because last semester in Math 99 you did talk about functions, and you talked about relations. So a relation, remember, is a set of ordered pairs. That's how we defined relation. It's just a set of ordered pairs. So example of relation, so these are examples. So number one, we could actually have a set of ordered pairs. So we could have 3, -2. We could have another ordered pair that could be 0, 5. We could have another ordered pair 2, 3, and so on. So it could be a set of ordered pairs, just like this. All right, so a relation set of ordered pairs, you see a set of ordered pairs. How many ordered pairs are in this set? 4. But we also can represent a relation by an equation. So one of the things you have to do in your test day is to graph a line. Well, those are relations because a line is made up of a set of ordered pairs. And how many ordered pairs were on that line that you drew in the test today? There were 2 ordered pairs on that line. So if I take this one right here that someone did, although the person forgot to do an arrow, but that's fine. You're telling me there are only 2 points on this line?
No.
No. How many ordered pairs are on this line? An infinite number. Okay. An infinite number of ordered pairs are on that line. So we could represent a relation as an equation. So we could say another example would be y equal 2/3 x minus 2. That's an example of relation because I could represent that relation as a set of ordered pairs. I can find out an x coordinate and a y coordinate, and there are, in this case, an infinite number of those. Now, with some of these, you can recognize what kind of graph that relation represents, and that's important. It's important to recognize this at this point for you. For example, if I wrote this equation, this relation, you should be able to tell me what the graph is. What kind of graph is this? It's a linear equation, so the graph is a line. It's a line.
Can you zoom in again, Mr. D?
Can what?
Can you zoom in some more again? There. Perfect.
All right, so that's a line. All right, here's another relation that we've talked about in here. That's a relation. It's an equation. I can represent that as a set of ordered pairs. At this point, I'm hoping you know what the graph of this looks like. What is the graph of this?
Parabola?
No, it's a circle.
Oh.
You have an x squared and a y squared. That's a circle. Number 4, y equal x squared minus 3. Last semester you had that. That's a parabola. Okay, that's a parabola. So some of these, based on your experience from this course and the previous course, you can recognize what kind of graphs those represent. So another relation would be something like this. X equal the absolute value of y minus 2. Now, before we look at that one, I didn't mean to put that number 4. Let's put number 5. Number 6, y equal the absolute value of x minus 3. Let's talk about this one, number 6. That's a relation, because I can represent a set of ordered pairs. Now, at this point, we didn't do anything with the graphs of those in this class so far, but you had this last semester, the absolute value. Remember what the shape of the absolute value graph looks like? It's that V. That V? So that's the shape of an absolute value graph. It looks like this, the V. All right. Now, don't confuse number 5 and 6. Number 5, the shape is not the same as it is in 6. It's different. So we're going to talk about that. Now, but all these are relations to begin with. There are relations. I can represent all of those as set of ordered pairs. But not all of them are functions. So let's talk about a function. A function is a relation. A function is a relation in which for each x coordinate there is exactly, and you remember the rest of this?
One Y coordinate.
One y coordinate. All right, so that's something you had last semester. It was on your final exam last semester. You had to determine whether a set of ordered pairs was a function or not. So a function is a relation in which for each x coordinate there's exactly one y coordinate. So let's start out with an easy kind of relation, and that would be where the set of ordered pairs is actually given. So of all of these, of all these right here, unless you know what the graph looks like, then number 1 is probably the easiest to deal with. So let's look at this example. So I'm going to write this set of ordered pairs, and the directions will say determine if the relation is a function. So determine if the relation is a function. And then determine the domain and range. So in your test today, you had to find the domain and range of a circle. So same idea, determine the domain and range. Okay, number 1, let's suppose you had this. So go ahead and write this down. So it's going to be a finite set of ordered pairs. So let's say we had 4, 5, that ordered pair, my other ordered pair is 6, 7, and then let's say 8, 8. So let's say that was my set of ordered pairs, my relation. How many ordered pairs is in that relation? 3. So it's a finite set. So finite versus infinite. Finite meaning you can count them. I can count how many there are. How many are there? 3. Now the best way to think about that, especially when there are a lot more ordered pairs, there's only 3 here, so it's easy to do this without writing things down. But when a set of ordered pairs is given a finite set, it's easier to think about it by using a mapping. So I'm going to call this x, just kind of like a little oval right here, and then this will be y. All right, listen to the words. When x is 4, what's my y value? 5. So 4 gets mapped to 5. So notice I'm putting an arrow to 5. That's a 5. The next ordered pair, 6, gets mapped to 7. And then 8 gets mapped to 8. So I use the word mapping. But notice what I have. For each of those x coordinates, when x is 4, how many y coordinates were there? Just 1. When x is 6, how many y coordinates were there? Just 1. It was 7. And when x is 8, how many y coordinates were there? Just 1. So is this a function by definition? Yes, that's a function. All right, now we're going to talk about the domain. So when you did the one on the circle, when you wrote the domain and range, you had to write it as an interval. Remember that? You had to write it as an interval. Here, though, that's a finite set. So how many elements are in the domain? And remember, the domain is a set of x coordinates. How many elements are in this domain? 3. Finite set. So you're not going to use an interval, you can use a finite set. So it's going to look just like this, except you're going to say this. It's a set that has elements 4, what else? 6, comma, and what? 8. So that's your domain. Not an interval. It's just a finite set. If it's a finite set, you list them as elements. Just like that. What's the range then?
5, 7, 8.
5, 7, 8. Okay? All right. So that was a function because for each of those x coordinates, there was exactly one y coordinate. And then the domain, if it's a finite set, the domain is just listing your x coordinates, and then the range is listing your y coordinates. If they occur more than once, you list it only once. Okay? If they occur more than once, you list it only once. All right, let's look at number 2. Number 2. Suppose we had this. A finite set, negative 3, 5, 6, 2, 5, negative 1, 4, 5. All right, negative 3, 5, 6, 2, 5, negative 1, 4, 5. All right, how many elements are in this relation? I'm sorry, how many ordered pairs are in this relation?
4.
4. So it's a finite set. Okay, so let's first of all determine if it's a function or not. So use the mapping. Sometimes the mapping works for people. You don't have to use it if you don't want to. So I'm going to just say this. I'm going to say x, y. Let's do the first point. When x is negative 3, what's my y value? 5. Just do something like that. So far we're okay because when x is negative 3, what's the only y value that I'm associating with it?
5.
Just 5. All right, let's go to the next one though. When x is 6, what's my y value? 2. All right, so far we're okay. If x is 5, what's my y value? Negative 1. All right, so far we're okay. If x is 4, what's my y value? 5. Now remember, I already have 5 listed, so I only list it once. So just do this like this. Okay? Only listed once. Now, here's where students get a little confused with something that looks like this. Is this a function or not a function?
Yes.
Okay, so some people say it's not a function, some people say it's a function. All right? Well, let's think about this. What's the definition of a function?
X can only have one value.
For each x coordinate, there is only one y coordinate associated to it. So let's talk about that. If x is negative 3, what's my y coordinate? Does negative 3 have any other y coordinates? No. When x is 6, what's the y coordinate? 2. Does 6 have any other y coordinates associated to it? No. When x is 5, what's my y coordinate? Negative 1. When x is 4, what's my y coordinate? Does 4 have any other y coordinate associated with it? No. So is it a function? Yes, it's a function. You can have the same y value for multiple x's. Because definition says for each x, there's what? One y, and we have that here. So that's why it's a good idea to have that mapping, because sometimes students, when they see x coordinates with the same value and y coordinates with the same value, they think automatically it's not a function. Well, you got to be careful. Do the mapping and notice that for each x coordinate, there's exactly what? One y coordinate. So this is a function. Now let's talk about the domain. What's the domain? Negative 3, comma, 6, comma, 5, comma, 4. Okay. The range? 5, 2, negative 1. Nope. You already have 5 listed. So the range should only have how many elements in it? 3. 3 distinct elements. All right, number 3. All right, I have this relation. I have 0, negative 2, 4, 6, negative 1, 5, 0, 8, 1, 4. All right, so 0, negative 2, 4, 6, negative 1, 5, 0, 8, and 2, 4. 1, 4, excuse me, 1, 4. All right, so this relation is a finite set. How many ordered pairs are in this set?
5.
Okay, 5. All right, so let's determine if this relation is a function. So we can use a mapping. All right, so let's do the mapping. So my first order pair, when x is 0, what's my y value? -2. The next one, when x is 4, what's my y value? 6. When x is the next one, when x is -1, what's my y value? 5. So far, it looks like it's a function, but you got to keep on going. It's because for each of those x coordinates, how many y coordinates do we have so far? Just one, right? All right, when x is 0, what's my y coordinate? 8. All right, the last one. When x is 1, now I already have, no, I don't have 1, right? Okay, when x is 1, what's my y coordinate? 4. So is this a function? Oh, I'm sorry. I made a mistake, didn't I?
Yeah.
All right, so what did I tell you? If it's listed,
If it's listed, don't list it.
if it's listed more than once, you list it once. So you see what happened? So I wasn't paying attention. And it's going to happen to you as well. You're not going to pay attention. So you're going to say, well, there's just one arrow extending from this. And you're going to say it's a function. But that's why I said if it's listed more than once, only list it once, because you see that x value had how many zeros? 2. So list it once. So I'm going to go back and I'm going to make it correct this time. But it will happen where you're not going to be concentrating and you're going to list them separately and you're going to notice, hey, there's just one arrow extended from each one, so it's a function. Well, it's not. Because if I go back to that 0, 0 has what y coordinates?
5, 2,
-2, and what's the other one?
8.
8. So 0 has how many x coordinates? How many y coordinates?
2.
2. Definition of function says that for each x coordinate, there's got to be what? 1 y coordinate. Okay? So be careful when you are listing your x coordinates. If it's listed more than once, list it only once, so you don't fall into the situation where you look at it in an incorrect way. All right, so you all understand that number 3, it's not a function, right? Okay, so it's not a function. Because for each x coordinate, you got to have one y coordinate. Y'all see that x, when x is 0, there are 2 y coordinates? All right, so it's not a function. All right, but we can still determine the domain and range of this relation. What's the domain of this relation? Remember, only listed once.
0.
0,
4.
4, doesn't have to be in order.
-1.
-1 and 1. What's the range? -2, 6, 5, 8, 4. Okay? All right, now let's look at this idea for a moment. And for the remainder of this discussion, I'm going to give you a separate handout with graphs on it. So let's talk about that handout in reference to the graphs. So let me give this to you. All right, now in numbers 2, when we did 2 and 3, you understand that this relation was a finite set, right? That was a finite set. Now what we're going to look at is talk about whether these relations are functions in terms of if a graph is given. But notice that these relations has an infinite set of points. You understand that's an infinite set here, right? Even here, there's an infinite set of points on this circle. So these are not finite sets like we did in the previous problems. Okay, but you still want to determine if this relation is a function. Still talking about the definition of function. Definition of function says that for each x coordinate, there's exactly one y coordinate. All right, so you can't see it very well on the screen here, but use your own paper. When x is, let's say, 5, when x is 5, and I look at the point that's associated with 5, do y'all agree? And I'm going to use the rule to help me. So here's 5. So here's the point right here. Y'all see this point? When x is 5, you really can't give me an exact y coordinate, but there's a y coordinate associated with it, right? And how many y coordinates are associated when x is 5? Just one. Okay, if I go to 7, how many, I'm sorry, 6, how many y coordinates are associated with 6? Just one, whatever that y value is here, and so on. So notice that when x is 5, how many y values are there? 1. When x is 6, how many y values are there? 1. When x is, let's say, 3, you can actually tell me that one. What's the y coordinate? 1. When x is 3, I get the y coordinate of 1. When x is 0, you can actually tell me the y coordinate. What's the y coordinate when x is 0? 7. But notice that for each x coordinate so far, there is what? One y coordinate. All right, now if I go, let's say over here, let's say I extend this right here, and you're going to have to do that. You extend this, and let's say this is negative 1,000. Negative 1,000. First of all, am I going to get a point on the graph?
Yes.
Yes, because you got to notice that you don't see very well, but this thing keeps doing this, right? So at some point, you will get a point on the graph. So when x is I didn't mean negative 1,000, I meant what? Positive 1,000. When x is positive 1,000, I do have a point on the graph, and how many y values are there? 1. When x is 1 million, do I get a point on the graph? Yes. 2 billion, and so on, right? If I talk about in terms of negative 1 million, negative 1 million, am I going to get a point on the graph? Yes. Okay? But notice that for each x coordinate, there's exactly what? One y coordinate. For each x coordinate, there's only one y coordinate. So is this a function? Mm-hmm. Yes. Now there's something called the vertical line test. Remember that from last semester. So your final exam last semester, they gave you some graphs and you asked to determine if they were functions or not. You just use the vertical line test. So the vertical line test says this, and I don't want to mess this one up, so I'm going to use another one. The vertical line test says this, that if I draw a vertical line anywhere on the graph and it intersects it once, then that relation represents a function. And the reason it works is because when I used a ruler and I did this, that indicated that for this x coordinate, there was only what? One y coordinate, so it intersected once. For this x coordinate, there was exactly what? One y coordinate. So the vertical line test intersected once. Okay? So that's why the vertical line test has a very good relation with what we just talked about. All right, so this is a function. Yes or no? Yes, that's a function. Now let's talk about domain and range. Okay. So remember when we did the circle and you had a circle in your test days? Anyone still taking a test? Everyone's done? All right. So we did this circle, and the reason I'm asking is because you had that in your test. All right. So we did this circle. We talked about domain and range. Remember, domain, we took the ruler and we went from left to right. Remember that? Mm-hmm. Okay. So notice that for this circle, though, remember domain instead of x coordinate. Is this x coordinate right here, this x value that I'm pointing to right here, is that x value, whatever that is that a point on the graph? Does that represent a point on the graph? No. So this is not going to be, that whatever this x value is right here, that is not going to be part of my domain. In fact, the smallest x coordinate, and just assume that each one represents 1, would be negative 1. So you go from negative 1 with a bracket, remember that? All the way to what? So we went from negative 1 all the way to what? Oh, just count, I'm sorry. That's 1, 2, 3, 4. I'm going to put a 4 here. 5, 6, 7. That's 8. 9, is that correct? Y'all got 9? All right. You thought what?
I missed that one.
Okay. Now let's talk about the range. The range is a set of y coordinates. So you go from bottom up. So when I go from bottom up, what's the smallest y value I get to? Negative 2. And remember, when we talk about interval notation, you always go from smallest to largest. So that's why we go from the lower portion to the higher portion. So I go from -2, and then the largest y value I get, let's count these. 9, is that correct? Is that correct? 1, 2, 3, 4, 5, 6, 7. That's 8. 8. All right. So the units aren't there. The numbers aren't there. So you're gonna have to be very careful when you count these. All right. So that's domain and range. All right. Now, is this a function? No, it's not a function because you can see right away when x is 4, and I use that ruler to help me, when x is 4, I get 2 points on the graph, right? That up here, and then this one right here. Which means that when x is 4, my y values are, and what's this y value? 8, and what's this y value? -2. According to the definition of function, for each x coordinate, there's got to be how many y values? 1. So if you use a vertical line test, it fails the vertical line test in an infinite number of places. Now remember, when I'm drawing that vertical line test, in order for it to represent a function, it's got to intersect everywhere how many times? Once. And that's the relation to the idea of that definition of function. So notice that for this x coordinate, there are 2 y coordinates. For this x coordinate, there are 2 y coordinates. Now let's go back to number 1. Let's talk about the range is the easiest in this one. So let's do the range first. So to find the range, remember the range is a set of y coordinates. So you go along the y-axis from bottom up, just like this. So what is the smallest y coordinate I get to? 1, right here. So my range will be from bracket 1, comma. All right. Now, where is the largest y coordinate? Or is there a largest y coordinate associated? No. There is no largest y coordinate. You cannot tell me that the largest y coordinate is 9. You cannot tell me the largest y coordinate is 10 or 1,000 or 10,000. Why? Because those arrows, you keep going up, right? But what's that idea called? Infinity. And remember, when you talk about infinity, negative infinity, you always use parentheses. So that's your range. So our range is from 1 to infinity. So remember, bracket at 1, parentheses for infinity. Now let's talk about the domain. So the domain is a set of x coordinates. I'm going to ask you this. Let's say this point right here, this right here, is -100. -100. I want you to think about this. When x is -100, do I get a point on the graph? Yes or no? Yes. Is that the smallest x coordinate? No, because remember, it keeps doing this, so that means that there is no smallest x coordinate. So you're going from what idea now? Negative infinity. And is there largest x coordinate? Do I stop here? No, there's some other x coordinates on that graph that's beyond that. In fact, what's the idea I use?
You keep going.
Yeah, infinity. So the domain is from where? Yeah, negative infinity to infinity. Okay? All right, now let's look at one more. In number 3, right here, very quickly you can tell me, function or not a function?
Function.
It's a function because it passes the vertical line test. In fact, if you use a ruler as a vertical line test, knows that ruler intersects the graph once, which means that for each of these x coordinates, there's exactly what? 1 y coordinate. So this is a function. Now let's talk about the domain and range. The range in this case is easy again, so let's write the range first. So your range is, remember, you go from Bottom up. Is there a smallest y value on your graph?
No.
No. Why not?
Because
Why is negative 100 not the smallest y value? Yeah, because of these arrows. So since there's no smallest y value, you're going to use what idea? Not infinity, negative infinity. So you're going from negative infinity. Is there a maximum y value?
Yes, there is.
Right here, isn't it? What's that y value?
4.
4. So your range is from parentheses, make it look like a parentheses, negative infinity all the way to 4 with a bracket. And then finally, the domain. What do you think the domain is? What do you? Negative infinity, positive infinity. Because you cannot tell me that there is a smallest x value because of these arrows right here. There's no smallest. If you think there's a smallest, let me know which one you think it is. Is it negative 100? You think that's the smallest? Well, let's say this is negative 100 right here. Is negative 200 on the graph? Yes, it is. Negative 1 million, and so on. So you're going from negative infinity all the way to what? So I'm going along the x-axis. See, I'm going along the x-axis. Every point, every x coordinate, every real number for x is going to be associated with a point on the graph. So the domain is from negative infinity to positive infinity. So what I want you to think about then is this. So let's look at that other worksheet.